Proving sine product formula using Digamma function. So basically in this video we will prove this formula using the most beautiful formula of Digamma function, which is something like this. Digamma of 1 plus x equals to negative of Euler-Mastroianni constant plus nth harmonic number. So using this formula we will try to prove the sine product formula. Okay, so now let's begin. First of all, we can write Hn in the form of infinite series. Yeah, basically nth harmonic number. Let's say if you have to find h of 3, it's just 1 plus 1 by 2 plus 1 by 3. Yeah. Okay, negative of Euler-Mastroianni constant plus sum from n equals to 1 to infinity 1 by n minus 1 by n plus x. Okay, so basically now if you have like doubt of how will this give us the Hn, so basically you can look like you can see like this. Basically if we have x equals to 3, yeah, now we need h of 3 is 1 plus 1 by 2 plus 1 by 3, and this sum also gives us 1 by n will give us 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 and such sum, and minus n plus x will do, n going from 1, yeah, so we will have 1 by 4 plus 1 by 5 plus 1 by 6 and so on. So all the other terms will cancel out and we will just have these three, which is what h of x means. So this is how this formula works to give h of n. Yeah. Okay, so this was just some basic insights. Okay, so now we have this formula, and if we now try to find digamma of 1 minus x, we will have negative of Euler-Mastroianni constant plus sum going from n equals to 1 to infinity 1 by n minus 1 by n minus x. Basically substitute x by minus x. Now we will try to subtract the first equation from second. That gives us digamma. This is basically just to use the reflection property of digamma. Yeah, to use the reflection property and get some trigonometric stuffs, we are doing this, and minus constant will cancel out, and we will have sum from n equals to 1 to infinity. We will first have 1 by n plus x and minus 1 by n minus x. Okay, now fine. Now we know the reflection formula of digamma. Digamma of 1 minus x minus digamma of x is pi cot pi x. Yeah, so we will use that, but first we don't have digamma of x over here, so let's make that. Let's make this as digamma of x plus 1 by x. This is just the property of digamma. Minus sum is equals to sum from n equals to 1 to infinity 1 by n plus x minus 1 by n minus x. Okay, now we have digamma of 1 minus x minus digamma of x, so that pi cot pi x, and we have minus 1 by x, which you can take to other side, and that will be plus 1 by x plus sum from n equals to 1 to infinity 1 by n plus x minus 1 by n minus x. Okay, now after this let's try taking the integral in both sides, and with respect to x, so integral with respect to x, and for this one pi is constant, and for cot we have ln of sine pi x by pi. Over here we have ln x plus sum from n equals to 1 to infinity ln of n plus x minus ln of n minus x by minus 1, and also a constant should be there. Yeah, so let's just add a plus c in this side. Yeah, because we're doing integration we need a constant, and pi cancels out. Yeah, and the minus minus will become plus. Yeah. Now since we have ln in every term, let's try to raise this to the power of e. Then we will have e to the power c times sine pi x equals to x times, now this will be infinite product of n going from 1 to infinity, and this will be n plus x times n minus x. Yeah, that is n square minus x square. Yeah. Okay, so now let's try to bring x to this side. Now this is already looking like the sine product formula. Yeah, but no, we don't have the constant value, so that's the problem. 1 to infinity n square minus x square. Now to find the constant, what we can do is we can take limit. Yeah, for the whole expression we can take limit x tends to 0. So in that limit we will have e to the power c, and this will just be, we can add pi over here and a pi over here. Now sine pi x by pi x, where x going to 0, this will just be 1. So we have pi times 1. Over here we have product of n from 1 to infinity, and this is n square. Yeah. Now we can see our constant e to the power c is just a product from n equals to 1 to infinity n square by pi. This is the e to the power c. Now let's substitute e to the power c in the original equation. Yeah, over here that will give us, in this, if we substitute e to the power c as product from n equals to 1 to infinity of n square by pi, and then we have also have sine pi x by x. This is equals to product from n equals to 1 to infinity of n square minus x square. Yeah. Now let us take this product to the other side, and that gives us sine pi x by pi x is equals to product from n equals to 1 to infinity n square minus x square by n square. Yeah. And now let's divide that, and we get the sine product formula from the Digamma function. Yeah, and this gives us product from n equals to 1 to infinity 1 minus x square by n square. This is the answer, and so we have proved the sine product formula. Yeah, and basically the flow of the solution was something like this. If you have to see the flow of the solution, first of all we use the definition of Digamma function, or basically the well-known formula, that is minus masculine constant plus Sn, and we basically found some values of 1 plus x, 1 minus x, and then subtracted so that we can use the reflection formula. And after that we took integral. Yeah, and then after taking integral we raised to the power of e, and then try to find the value of constant using limit, and we got the formula. So that was it. Hope you enjoyed this proof. Thanks for watching, and look forward to seeing you in the upcoming videos too.